So healthy, successful Agile teams rely on a robust continuous integration implementation as the hub of their Agile infrastructure. Many of the Agile practices depend on continuous integration in order to provide their full value. Today's session will cover best practices for transitioning to continuous integration, as well as show the strong link between continuous integration and one-piece flow, unit test, short iterations, and how this affects distributed and large-scale Agile teams. Damon Poole is our presenter today, and he is the founder and CTO of AccuRev, a leading provider of Agile development tools. Damon has over 18 years of software development methodology experience in process improvement, spanning from small co-located teams all the way up to 10,000-person shops doing global development. He writes frequently on the topic of Agile development, and you can read his blog at damonpoole.blogspot.com. And with that, I'll turn it over to you, Damon.
Thank you very much, Leanne. Welcome to everybody in the audience. Today's topic is about continuous integration and how it forms the hub of a healthy Agile organization. That works both ways. The continuous integration both is a leading indicator of the health of your Agile team and reinforces the Agile practices and makes them more effective. So the topics that we'll be talking about today related to continuous integration are user stories, shared code ownership, one-piece flow, all the things that you see here. We'll be touching on that link. Okay, so before we dive into continuous integration and the links, let's step back for a moment and look at how traditional development works. So in traditional development, you have various phases: specifying, designing, coding, integrating, etc. Now you may call them slightly different, use different terminology, use requirements, or any number of terms at the various stages. But at the end of the day, you have a set of stages in a waterfall. Now, of course, most people don't do strict waterfall anymore. There's some overlapping and that sort of thing. But Agile development and traditional development are different enough that you can talk about it that way. Okay, so what we do is we have these stages, and I'm going to abbreviate them with these letters and colors. And you have a lot of work that you need to do for a particular release. Some things are big, some things are small, some things are medium. And so it seems to make sense to use economies of scale, do a whole bunch of things up front at once. So before I start writing any code, let me make sure I know exactly what I'm going to do. So do all the preparation up ahead, all the specification, all the design. I'm going to do that up front before I start coding. All right, so that seems to make sense. So that would end up with a specification. I'm going to take all the specification that I would do for any particular issue, put it all together, and do all the design, etc. The problem there is it starts to break down. People take shortcuts, and also it has this very painful thing, which is one of the topics we'll be talking about today, which is Big Bang integration. So with Big Bang integration, people are going to work in isolation for months, and then finally bring it all together where it's never been integrated before and see if it works. Okay, other problems that you run into, maybe something gets under-designed. You just didn't have enough time. People are saying, hey, let's get coding. All right, so then when it comes to coding, you take some shortcuts. Maybe there's some code that you didn't write because the design didn't cover that, so you didn't need it. You have to do all of the integration, but maybe there are some tests you wanted to write that you realized, well, we're getting time pressure. We don't have as much time as we thought we were going to have. There's some low-value stuff that we don't have to test as much. We'll get to that later. In effect, there are tests that you need or believe that at one point that you needed that you didn't write. Other areas that you do write tests for, perhaps you don't write as many tests as you needed to. There are some corner cases that might be important, but we'll do those another day. And then even if you have the tests in a test plan or automated, they don't always get run. Now, why is that? Well, if your test suite takes a while to run, especially if there's a lot of manual testing, it may be that you run the whole thing once, trying to do the right thing. It takes a long time. You find a lot of problems. You fix the problems. Are you going to run the whole thing all over again? You'll try to do just spot checks as much as you can. So at the end of the day, what you ship may not have been through, the actual binaries that you've produced may not have been through a full test cycle. Sure, you ran the whole test cycle at one point, but not on code that you shipped. Okay. And worse than that, often when you get through some phase of the coding, the project may get canceled or shelved, right? So that's a complete waste. All of the specification, the design, and coding that you've done is completely lost. And if you ever get back to it, it's likely that integrating that work back into the current code that you have is going to be too difficult, and you start over again. Okay, so let's take a look at how Agile works. Agile starts with a backlog of issues from top to bottom. This is something that you might do most ideally in an Agile project management tool, such as provided by version 1. So you have the backlog, and the customers and the product owner work together to figure out where is the most business value for the organization. That may be things that are going to bring in the most money, that are going to reduce costs the most, or some other thing that is the business driver for your organization. Then you're going to break things down into iterations. An iteration is what can I get done, and it may be between 1 and 4 weeks, sometimes it's longer. What can I get done in that time frame with the resources that I have? And over time you'll figure that out with velocity, which is a whole other topic. Okay, so within an iteration, we have various things that we need to do. That's going to be made up of the various user stories for that iteration. An example of a user story is, as a user, I want to be able to order with a single click. That's much more succinct, and everybody from customer all the way to test can understand that. It's much easier to understand than we're going to use a JDBC connector with this, that, or the other thing, and then at the end of the day somebody says, did you mean you want to order with a single click? Much easier to just start with that. Okay, so within a user story, each user story represents one item of work, and that's going to include, at the low level, all of the specification, the design, the coding, the integration work, writing the tests, and running the tests, just as though you were doing a single patch for a single issue, whether it's enhancement or a defect. Right? So it's not done until all of these things are done. You can't say that it's done until it's integrated. Just because you wrote the code does not mean it's done. Okay, that work is going to be done by what's called a whole team. The idea behind a whole team is that you have all of the people that you need in order to do the work to complete that user story, everything, whether it's a DBA, usability expert, a GUI person, back-end server person, whatever it is. Everybody needed to do that work is on that team. This breaks down the idea of having silos where you have a QA group and a development group and a DBA group. Now that's very difficult to do and can often include dealing with politics and that sort of thing. But ideally, you want to have what's called a whole team. Okay, so that whole team is going to produce all of the changes, the file changes or new files, whatever it is, plus the tests associated with those changes to fulfill the user stories. As you're going through the iteration, you're going to track your progress with a burn down chart. Again, that's something that an Agile project management tool can do for you. At the end of the iteration, you have the product. This product should be in shippable form, and what shippable means is that although you may not be releasing it, you could. Now, maybe you still need to do stress testing or something that takes a really long time to run, or some usability testing at the end or something like that. But the process for shipping it now should be just the overhead of shipping, not testing, not coding. Everything should be done, done, done. All right. Now, to make sure that you've done what you said you were going to do, you do an iteration review where the product owner goes through what was supposed to be done by the team and verifies by having it either demoed or some other evidence that shows that the work was actually done. And the product owner in that case is a proxy for the end user. If you can get end users to be part of this review, that's even better. And then, of course, the retrospective. Okay, now that was a very quick overview of Agile development because I'm going to be touching on a lot of these things, relating them to continuous integration. Okay, one more thing on the way to that is to show that people's memory is not that great. That's why breaking things down into short chunks and which is something that continuous integration goes along with very well, is so important. Customers and product management talk. Product manager produces an MRD after 2 months, gives it to the architect. Another month gives it to the developers. 4 months later gives it to the testers. So if a test person has a question, they go to the developer, and the developer worked on it 2 months ago, chances are he's not really going to remember all of the gory details about what he was doing. And then if he has to talk to the architect, same problem. Product manager, same problem. Talk to the customer, they may say, I really don't even remember asking for that. Perhaps you were asking, perhaps some other customer was asking for that. Lastly, the customer gets the full product and says, close, not quite what I was looking for. Let's try that again. Now in Agile development, and that was a 9-month period. In Agile development, within that iteration, the conversation between customers and the product owner, the team, the representative on the team, talking to the customer, is going to be done in a very short period of time. So if any question comes up, it was only a month ago that that we talked to the customer. It's much more likely that they're going to remember that conversation and be able to give us additional details and feedback. Even better, and this is where continuous integration comes in, the conversation between developer, the person doing testing, and the person doing the documentation probably is going to happen every couple of days. So the developer has a small user story, a small amount of work that he's going to work on, a small chunk of work, and if the test person says, I have a question, why doesn't this work? Why is it working this way? What's going on here? How might we fix this? The developer just did it. So in his mind, it's going to be very fresh what the problem might be, as opposed to having to dig through the code and remember and look at the specs and all that sort of thing. All right, so now let's circle back to continuous integration. If we look at the traditional cycle with specify, design, code, integrate, write, test, and test, that integrate cycle is pretty small. Now, of course, there may be cases where you're bringing code together early and all that sort of thing, but it's not official until you have that big bang near the end. And while I've artificially divided these at the end between integrate, write, test, and test, often they sort of blur at the end. You're doing a lot of integration and test writing and testing all at the same time at the end. And that's the crunch time. Now, if you're doing continuous integration without Agile, you can definitely do it, and it's going to be the most effective here at the end when you're making lots of small changes, integrating, finding problems, fixing them, integrating, finding problems, fixing them, much like just plain Agile. In Agile development, we're going to do a couple of things a little bit differently. For each individual user story, each individual unit of work, we're going to do the specification just for that user story. Just enough design to cover that user story. Just the code and the tests for that user story. And the tests we're going to try to write as early as we possibly can with that code so that when the code's done, we can run the tests and integrate. This is a principle known as one-piece flow, and it comes from Lean, where a lot of the Agile principles actually are derived from Lean. Okay, so that's everything in a nutshell for one work item, one user story. All of these things are going to be linked to one user story. And everything that we would have done in the traditional way, we're now going to do in iterations. And so you can see that I've broken this out so that you can see all of the work items that have been done and all of the stages for each one. And you can see that we're doing a little bit of everything over time and coming together at the end of that iteration, each iteration. Where this is different here is that rather than put the integration all at the end and have that big bang and the panic and all that problem at the end, we're able to do the integration over the full lifetime time frame of that release. So it's really continuous integration. Right, because installing a continuous integration tool does not mean you're doing continuous integration. In the example of traditional development above, you may be doing continuous integration at the end, but continuous integration means that everything is integrated continuously and you have a product that you can ship pretty much all the time. Okay, now that work is done by the whole team. It's very difficult to do this without a whole team. So if the developer does a bunch of work and that sits there for weeks or months, it's very difficult to do continuous integration, right? Because the tests aren't there, you haven't actually integrated it with the main line. That is not continuous integration. So to get good continuous integration, you need a whole team. And if you have a whole team, continuous integration is going to reinforce that, because whenever you go, onto the rumble strip of getting away from the whole team, continuous integration is going to remind you. Okay, so there are all the integration points, and you can see this really is much more continuous. All right, so now on to unit tests, refactoring, and shared code. How does that impact continuous integration? What's the relationship there? Well, shared code ownership means the code can be refactored anywhere. The reason that shared code ownership is important in an Agile team is that if you are a whole team, you may be working on something, a user story, that impacts more than just one section of code. Maybe it goes across lots of places in the product. So that team needs to be able to make changes to that code. Now, I'm not saying that anybody can do anything, and maybe they need to consult with somebody that knows more about that code than they do. That makes perfect sense. But in order for a whole team to be effective, they do need to be able to make changes wherever. Now, to make changes wherever, that is a little scary, you need a safety net. To have that safety net means a combination of unit tests and continuous integration. So the unit tests are helping me feel more confident that when I change code, the unit tests associated with that code will find any of the simple or dumb mistakes that I might make. Integration testing and that sort of thing still has to be run. And if you can run that continuously, that's great. If you can't make changes easily, if the code is difficult to change, changes are going to take a long time to make, and you're not really going to get continuous integration, right? Because if it takes you a week to make a simple change because you didn't understand the code, that's frequent integration. And to make that easier, you need to be doing refactoring all the time. Reorganizing the code, even though it's going to have the same behavior, but reorganizing the code associated with the changes that you make for a user story to be easier to maintain, understand, and to use. So if you have some spaghetti code, you would refactor it, add unit tests if they're not there, and then the next time through, it'll be that much easier to make changes in that area. Also, if you're making changes all over the place and you don't have continuous integration and you don't have unit tests, it's more likely that a problem is going to fester or be hidden for a long period of time. Whereas with continuous integration and unit tests, I make a change, I check it in, there's a problem, bang. It tells me a little bit later there's a problem, and I have to go and fix it. Stories cannot be considered done until they're integrated. So one of the things that I commonly see is, especially if you have multiple Scrum teams or multiple whole teams, is that the whole teams are doing continuous integration, that as a team they're doing whole teams and integration, all that sort of thing. But continuous integration does not mean integration to your team. It means integration to the whole product. Anything that you're shipping as a unit must be integrated continuously, even if you have multiple teams. Now that's easier said than done, I know, but that's the goal. And the story really should not be considered done until it's integrated on the main line and the main line builds and all tests pass. So that means speed is of the essence here. You can't get continuous integration unless things are moving very quickly. So one of the keys to this is the unit test. Now, people often say, it doesn't make sense to do all this testing all the time. I'm going to get more bang for the buck if I do the testing later. Okay, well, let's see what might happen if we were to change things a little bit. All right, so let's say we do all our unit level testing, all our integration testing, all our system testing at the end. Okay, so we're going to put our tests in there and they're going to probe into this black box, so to speak. And what problems will they find? Well, any problems that I have at the unit level are likely to block my ability to test at the integration level. If it doesn't, if a test doesn't pass, right, the integration is less likely to pass. So there may be problems that are there that I cannot find on that first pass. So when it's 2 weeks to ship and I have all these problems and a bunch of problems I don't know about, it's no wonder that as I start testing, it seems like the number of bugs go up as I find problems. That's because you're removing impediments to finding other problems. So if instead I'm running the unit tests all the time, I'm going to find those problems and eliminate them so that when it comes time to integration level, to do integration level testing, the only problems that I find are problems at the integration level, not unit level tests. So that's going to mean fewer passes of the integration level testing to flush out unit problems. If I could do integration level testing more often, that's going to mean that when I do all of my testing at the end, I'm just going to be doing a validation that unit and integration is fine, and the only problems left to find are going to be the problems that could only be found when I do the system level testing. Okay, so automating as much as you possibly can, the unit tests and the integration level tests are going to allow you to do testing continuously much more easily. All right, so now let's take a look at the hardware you may have laying around. If you're doing traditional development and you have a nightly build, big deal. You know, I've got an old machine from 1999, and it does our single nightly build. And in this example, I've got 100 developers all making changes. They make a lot of changes every day. All of those changes are bundled up into the nightly build, and every 24 hours I find out whether or not all 100 developers made no mistakes. So what's the likelihood that if you have 100 developers in a 24-hour period, they've injected no problems into the nightly build? Well, I can tell you from experience it's pretty much zero. The only way to get around that is to tell people to hold off on checking in until we resolve this problem, and that can take days. I've seen people go weeks without a good nightly build. So if you're doing Agile development, the idea here is that I'm going to be continuously building and testing. So in a short period of time between builds, I'm going to have a much smaller number of changes, much smaller window of opportunity for somebody to step on somebody else's changes and have a problem in that build. So during a particular day, I might be doing a build and test cycle every hour, or perhaps on every single check-in. Now, some folks may not be able to do that initially. Maybe your build goes overnight. Maybe the build takes 5 hours. Maybe the build takes 10 minutes and the testing takes 10 hours. There are many reasons for that. It could be just lack of hardware. But no matter what, you're going to be doing far more builds with Agile development, especially if you're doing continuous integration right. And all those builds going through that one machine, that's just not going to work. So time to upgrade the hardware. Now that rack may look a little scary. You may be thinking that's a lot of money, but these days, getting a commodity rack off the shelf, so to speak, that's not going to set you back as much money as you might think. And the productivity gains you're going to get for that big team far outweigh the cost of that hardware. All right, so how do I get ready for continuous integration? Well, there are two parts here. There's the build process and the test process. So how do you get your build process ready? It has to be a one-step build. It has to be something that, as a developer, I click a button, I run a script, and I don't have to think about it. Everything just works. So that the build that I, as a developer, do is the same that the automated continuous integration system is going to do. Because if the continuous integration system uses one build method, and it spots a problem and I need to fix it, but it works on my machine, that's no good. Everybody has to be using that same build process, and the results have to come back very simply. There can be no waiting hours for somebody to manually pore over the results to see whether or not there's a problem. So that may be a combination of awk, grep, sed, that sort of thing. But also many of the continuous integration systems out there will do that for you, especially if you're using something, a standard build system. Okay, so One way to check this is to do that for the nightly build. So that may not seem like much of an upgrade, but then move to on-demand. Can I do the builds on demand? And lastly, get it into the continuous integration system. It's pretty much exactly the same for the test. All the same sort of processes, except you want to start moving to automated testing. Now, if you have a very large regression suite or a manual test suite, and I'm not talking about the ones where it really does require a person to type something or touch something or move something. I mean the ones that can be automated, but haven't been. Start moving towards it. You don't have to get all your tests there. Maybe you have a sanity test. If the sanity test, every time I do a build, fails, that's good information. I've got to at least get that working so that if the developer creates a problem where nothing works, finding that out on a regular basis, that's good. That keeps you from major trouble. Then maybe you move it onto a smoke test, maybe start adding unit tests, but you do need whatever testing you're going to be doing to be basically push button, one step. Everybody needs to use the exact same test process, and again, the results should be automatically summarized. Okay, now let's look at another common problem that happens when we try to scale out to many teams or to distributed development. Continuous integration specifies simply that we should be integrating to the main line, and it leaves it at that. Now, in this case where I have only 6 developers, each developer is making changes, and then when they feel like it's ready to check in, they check in. When they're ready to take changes from other people, they take them. So the triangles moving up indicate developers integrating their work, other people's work into their private work areas, and the triangles moving down indicate changes moving from the developer to his work area and then being checked into the main line. So on the main line here, we're going to do continuous integration, and if we're really doing Agile development well, we've got our user stories figured out, broken down into epics and user stories, what have you. And again, that's something Agile planning, Agile project management can help you with. Then we've got things broken down into small changes already. Right, so the time scale here is that I may, as a developer, individual developer, be making changes every couple of minutes, but checking in every hour, couple of hours, hopefully, at the very worst, every couple days. And less is definitely better. If I were to scale this out to many teams, all going directly to the main line, people are going to start stepping on each other's toes a lot more frequently. So if each developer has some chance of interjecting a problem, right, because he made a change, it worked for him, but he got changes half an hour ago, and during that half hour somebody else made a change, that means he hasn't actually tested against that change. So the continuous integration system is going to catch that, but it may mean that you have actually continuous noise, because the more developers you have, the more chances you have of breaking the main line, and also the more people that are impacted. That's actually an n-squared problem right there. So taking continuous integration to the next level, we can do multi-stage continuous integration. Multi-stage is for each team, they do continuous integration for themselves, and actually that's a fairly standard pattern. Often that's what people interpret continuous integration as. But really, you have to do continuous integration all the way back to the main line. Now, in this graph, integration represents the main line. And I'll talk about the other steps in a moment. So we've got 2 teams in this example, the team on the left, the team on the right. The team on the left is making changes and integrating them. And then when, as a team, they believe they're ready to integrate that change, they will then integrate that to the main line. So again, you should be integrating the work of the team to the main line as soon as possible, but no sooner. So if your CI fails, you should not merge your changes to the main line. Why would you want to impact everybody else? Conversely, if the main line doesn't build, why would you want to integrate those changes into your team? So the idea here is that for each team you have a branch, and you're integrating your changes to the branch and from your branch to the main line, from the main line back to the branch. Now, often people say, well, merging and branching is very difficult. That That may be true if you build up changes over a long period of time, months. But the idea here is that, again, all of these changes are small and mostly will go without conflict. And the number of conflicts that you're going to have is the same whether you're doing this or not. And you would do continuous integration for each team and also at the main line. You can carry this even further if you want. Instead of integration being the main line, it's the integration area. And then QA can say, hey, the main line works really well right now. I'd love to do some exploratory testing on that. That doesn't mean that QA is only at the end here. The QA person has already validated that the story is complete earlier. This is doing the things like exploratory testing. So I'm going to take what's in integration now, move it to the QA branch, so that I know exactly what I'm testing. If people then go on and make changes to the integration area, that's not going to affect me. Conversely, a follow-on to that is if QA says, hey, the stuff we've got on this branch is good, they can move those changes on to an area called always shippable, and then take changes from the integration area and start QAing those. That way, if there's a problem, QA can say, how has this changed from the last time we validated it? Development can say, how has this changed since the last time QA said it was good? A developer can say, how have I changed it since the last time somebody in my team made a change? Debugging problems then is isolated. If there's a problem in my team, I know it's either me or one of my teammates, not a problem that another team caused. Moving on to distributed, one way that folks, including myself, have thought of distributed development is where are they located? One of the ways that Agile works best is if you're doing co-located whole teams. So you may have a number of different development centers in different locations around the world, but each one ideally would be a whole team in and of itself. Instead of having QA here, development there, different QA areas, different development areas, whatever, a hodgepodge of mix and match, if you will. Instead, organized by the work that's being done. So in this example, the GUI is the responsibility of the team in India. They've got the test people that they need, the GUI experts, the usability person, whatever the skill set is that they need to do the GUI, it's all right there in the Indian team. The web team is in Austin, etc. Then the GUI and the web, maybe they have common components. That's the UI team. And the Austin group does the integration there. And there's a branch specifically for the GUI and the web team to integrate before they share the changes with everybody else. Because why should the other teams get that before it's integrated? Again, you want to integrate as often as you can, but no sooner. If CI fails at any level, you should stop integrating further upstream. Okay, so in conclusion, continuous integration is more effective when you're integrating to the main line continuously. It's more effective when you're doing Agile development. Now that doesn't mean that you can't do continuous integration if you're not doing Agile development. And in many cases, continuous integration is a stepping stone towards Agile development. You can think of it as the heart monitor that you install to make sure things are going okay, or to see how bad things are today. It does require changes to your process, tools, and hardware. For instance, if you have a build management system that doesn't support continuous integration, you either need to upgrade to the version that does, or consider buying or acquiring rather, a continuous integration system. One of the best ways to make sure that you're getting the most bang for the buck out of continuous integration is to have small stories. One way to do that is to organize your stories and have something that understands user stories in Agile development, for instance with Agile Project Management Tool. For things like SCM, that's something that Agile is very good at. You want something that has good integrations with continuous integration and with the other Agile tools that are out there. Continuous integration is much more effective than Big Bang integration. And as I said, really the takeaway here is continuous integration is your Agile heart monitor. Okay, well I want to thank you very much for coming. This is the time for question and answers now. And I would invite you to take a look at these resources. My blog is a good source of information on Agile. Agile has a good resource center, as does version 1.
Excellent. Thank you so much, Damon. We do have a few questions and would like to encourage the audience to continue to submit those. The first one is the multi-stage continuous integration sounds pretty complicated, but does it really work?
Yeah, that's a good question. It does sound complicated. In many ways, while it's a mouthful, many organizations are already doing some variant of that. So if you have a number of development teams, you're a large organization, or even, say, 30 people might be broken into teams of 10. You probably already are doing branching for integrating. It's just that you're integrating every month or every couple months and working as individual teams until that time. So you've already got most of the infrastructure there. It's just that instead of doing all of that tedious merging and resolving of conflicts and everything one big bang at the end, you're spreading it out over time. So if you do that and you introduce continuous integration, voila, you have multi-stage continuous integration.
Very good. The next question is, we're just getting started with Agile. Should we be factoring this in? Should we be factoring in continuous integration as we're beginning the initial implementation of Agile?
Absolutely. It doesn't take much to install a continuous integration tool, and a good first step is if you have some part of your build that's already automated, it doesn't have to be the whole system. It could be just that one thing you're validating every time somebody makes a change, that it still works, that it still builds. It still builds in your official build environment, not just that it builds on somebody's machine. Same for the test. If you have even some simple tests, even just a couple of unit tests that are automated and can be a single step to run those too. And then when people have that in place, they'll start adding things into that infrastructure, and the next thing you know, you will have a complete continuous integration system.
Very good. The next question is, this sounds very tool-oriented. Isn't Agile more about individuals and interactions?
Yeah, that's a good question. I get that a lot. Yes, absolutely. Agile development is primarily about individuals and interactions. But I think the way to look at it is, how do you get to work in the morning? Do you ride a bicycle? Well, actually, I'm sorry. Many people do. Do you ride a tricycle? Probably not, right? It's not the right tool for the job. So we are tool makers, tool users after all, and the question is not so much should I be using tools. You have to use tools. You use compilers, debuggers, all that sort of thing. The question is, what are the tools most appropriate for Agile development? And so, for instance, with continuous integration, to do continuous integration at all, you do need a continuous integration tool. And the idea is not to concentrate on the tool because, again, just installing it doesn't solve the problem. It's to make it so that as people, we have that valuable feedback about how things are going as frequently as possible. If there's a problem, we know about it right away. And then the people, the team, can go and use their creativity to solve whatever that problem is.
Good. The next question is, how do AccuRev in version 1 fit into what you've described?
Okay. Good question. I noticed actually as I was going through the presentation that I was talking more about Agile project management than I was SCM. So I think I pretty much covered that already, but just to recap on the version 1 side, if you're going to be doing continuous integration, you do need things broken down into small pieces, and something that will organize and help you organize your user stories is a very good thing there. And on the AccuRev side, we basically have multi-stage continuous integration built in. And so those are two simple ways, and I would invite that person to go and take a look at our various resource centers to get more detail on that.
Very good. Those are all the questions that we have as of right now, so if there's anyone else who has anything that they'd like to add, please do so. And Dan, turn it back over to you if you've got any other best practices or tips that you'd like to share.
I think that about covers it. Thanks for the opportunity. And I want to, again, thank everybody for coming to see us today, and do take a look at the various resource centers. There are a number of other good webinars in there, including a couple that I've done in the past. And thank you very much.
Thank you, David. Bye-bye.
Bye-bye.